Alright, we're going to get going. We've got some really cool stuff to show you today. I'm going to start with this. This is USB on one side, and then it has about 6 pins out on the other side. This is a USB to UART converter, okay? And so in other words, USB has taken over everything, and one of the things that we can do with USB is we can make like what we call a virtual serial port or a virtual COM port. I'm going to plug this into my computer. You can hear that my thing went dink here, and what we're going to do is, I don't know which one this is, but we'll look. Not that one. I'll get the hang of this as well. I think it's around 3. No, it's 2. Okay. Okay, so something that happened, so just to watch this for just 1 second as I plug that in. We'll bring video capture device nearly to the top, and bring this over. Sorry, this is still kind of new how. Okay, so I'm going to plug that sucker in, and you notice that one of the comms is going to go away, specifically COM 100. I'll show you where it is here as we go through this. What I'm looking at here is device manager. So right here, CP210X USB to UART. So this is under COM ports, COM and LPT. Okay, and this is the COM port that I plugged in that is there. Okay, there's not a lot of, don't worry too much about this, but it just exists, and this tells me everything that's in there. Turns out, so I've got this plugged in there as well. Okay, it has its own very own COM port, but it's limited. I don't know about the newer launch pads. I haven't played with mine yet. Maybe that's something I ought to play with. But then there's a couple built-in. These are the 2 built-in ones. I think COM 3 is the one that's actually in the back of the computer, and COM 1 is a dummy. It doesn't exist. But we have these 2 on COMs 100 and 82. Okay, and I just wanted to show you just a little bit of what's going to go on, what's happening with these. So once these show up as a COM port, there's another thing that we can do, which is I can bring that dude to the top. If I don't want to use a graphical user interface in Windows to see what COM ports are available, I can use the command mode, and you can see COM 100 came up, COM 82 and whatnot. And so this just delivers me, this delivers all the different capabilities, and so maybe, yep, it'll let me do that. Okay, so if I type, once again, if I type mode, it'll show me all the different COM ports that are available, including CON, which I think is also kind of a dummy, and we can scroll up and see there's COM 3, COM 1, COM 82. So you can do this way as well. This one doesn't give you as much information, but it is rather quick. Also, once you start using a COM port, it'll disappear off of this list. So going back to my video, I got it now. Once we go back to this video, what I'm going to do is I want to be able to talk out of, sorry, you can't see it, it's in my USB hub here, but I want to be able to figure out how to communicate with this with the rest of the world. I'm going to do that with something called PuTTY. Okay, and so let me see if I can find it. It's not there, so it's COM 4 there. It's capture 4. Okay. So what I have to do with this is I have to. This is PuTTY. What's PuTTY? I think this is 2. Maybe it's not. Maybe just capture. Nope, not that one either. Man, whole bunch of fun here I've got to keep track of. 4, not 4, 2, not 2, no, there's that one. I don't think I have one out, funny enough. Okay, so I'll have to make one. Sorry, this is making the different windows. Okay, so what this is I've just done a search, and this is an executable. Okay, and so we'll go to the download, wherever the download putty. Oops, I did not mean to do that. Download latest. And you don't want the installer, you want to get, doesn't matter 32 or 64, I'm pretty sure they're the same thing. You double click it and it'll bring us to the one that we care about. That's not the one we care about. I believe this one is number 3. Nope. Maybe number 2. No, I think it's number 4. Sorry about that. Okay, so this allows us to do a whole bunch of things. If you do SSH, this is usually our Windows portal to SSH, although I've found out that Windows 10 has a SSH client built in now, finally. And what I'm going to do is we have to type in our COM port and our baud rate. I'm just going to leave it at 9600. It's a good standard one. Okay. And something that happens, and it's 5, is it brings up this window here. Okay, well, what's this window? Well, right now I'm going to type in it and nothing. What I'm going to do though instead is I'm going to bring up our video capture device again. There it is. And we're going to grab this dude and bring it over so we can see kind of both at once. And what I want to do is bring that guy up. That's 4, I think, 5. Okay, so I've got both of those there. I've got a wire here. And what I'm going to do is 2 of the pins are marked RX and TX. And I'm just going to connect those two, which means I have the transmit and the receive connected together now. They're just connected straight together with a single wire. I'm going to come over here and I'm going to start typing, and it's going to show up. And that the reason is because the window is telling me what I've typed in. Okay, it's telling me what it's receiving, and it's transmitting to itself. We call this a loopback. Okay. So it's kind of interesting. It's just kind of boring right now, but since the input and output are both, the transmit and the receive are both at the same baud rate, they both are connected together, and there's going to be no communication issues. So far, so good. And the way that this is really going to work is there. Bring that guy up. If we look at this from this perspective, and we look at UART timing diagram, and we bring up something that shows this, what we'd do is, if we could, what we would do is we could look at, I don't know, that's probably a pretty good one, but this is all time. That one's probably it'd be nice if we had one that actually has time. Yeah, here, this one isn't bad. So what you can see from this is this actually does something called little endian. It does the least significant bit first. It goes 0 through 7 with a stop. And actually little endian is easier to shove bits into a register, just the way it works. And so what these do is the voltage is normally 5, or in our case 3.3. It drops for the start bit, and then it starts chunking off zeros and ones at the specified baud rate. And so that's how it works. And so all that needs to happen is your transmitter and your receiver need to agree on a baud rate. Okay. And so that's the basic of UART. And one thing that we could do, and I don't have it ready, is I could bring in a scope and look at this pattern. but I think that's going to take too long. But just believe me that it exists in what we're looking at. So this is what we've got going, and the next thing that we're going to do is I'm going to connect up our MSP 430 with our PuTTY terminal, just directly. And the way we're going to do this, and we're just going to test, is the two pins are 1.1 and 1.2, and I don't know which are which, and so I'm just going to plug them in and hope. Okay. And I'm going to plug them into TX and RX appropriately. That's the way that those are, and so I connected them, and hopefully they're cross-coded. Now I have to put some code onto my microcontroller, and so I'm not sure if, I don't think I have that window capture up. But here's Code Composer. What I'm going to do is I'm going to make a file new project, something that we're very familiar with. It's going to ask me what I want to do with this, and it's going to be UART test. Okay, we're going to select the right one, G family, go down to our G2553. So this is really good review for all of you. I'm going to do an empty code, and someplace I have it already copied. There's some example code that if you want to, it's not very hard to find. But here's our example code. Let me explain this to you just really briefly. So it's our standard include. This is going to turn off the watchdog timer. This right now we don't need, so we're just going to do this. So this is using the special selection register of port 1 and special selection register 2 on bits 1 and 2. There's a lookup table someplace, and this is driving me nuts, but there's a lookup table someplace that that tells us how to do this, but this is just example code, so it's already there. This tells it to use the internal clock. This is interesting. UCA0BR0 is 104, and that's the lower 8 bits. And this is the upper 8 bits of a divide. This is telling it how many clock cycles between bits. And the way that we're going to think about this is, here I am in MATLAB, we're just using it as a calculator, and if my clock speed is 1 million, which it is, and I divide that by 104, we get 961543. Now we have to use whole numbers, so maybe we want to, okay, that was a little bit big, so let's divide it. No, we don't want to do that. Oops, I did 1 e to the 6 divided by 105. That turns into 95238. Which one's closer? 96154. That's close enough if we're off just by a little bit. And so that's why it's using that. Now what if we want to do another common baud rate is 115200? Okay? What if we wanted to know what that divide factor is? 1 e to the 6 divided by 115200. And that gives us that our division should be 8.68 rather than 104. In other words, we'd have to wait 9 cycles. Now, that's getting to the edge of my abilities to trust it. And so what I would do is I'd bump up my clock speed to 16 megahertz, which we are allowed to do. And I'd have to change that in there, and then it turns into a divide factor of 139. Let's go really slow now. Let's say that we're at 16 megahertz on our clock speed of our microcontroller, and now we want 9600. Now, what I want you to notice about this is 1666, okay? And that's or 1667 really is what it's going to be, right? And so the problem is that's greater than 254. And so this one we'd have to divide into two different bytes. In this case, it would be 0x 6 for the upper byte, so that's going to be the UCA0 BR0, we'll do BR1, and then 06, and then the other one is going to be 0x83. Okay, and so let me see if we can get this. In this case, our clock is running at the normal baud rate, or the normal 1 megahertz clock rate, and so it's just going to be 104. For the divide factor. Let me see what else. We're setting the modulation pattern of this guy. We are setting the interrupt enable for the RX, for the receive. We have an interrupt enable. We're going to do a global interrupt enable and then go into an empty loop. So let's look at what's going on here. This is the interrupt, and so all that's going to happen, there's a couple things that we can do. I'll change a few things as we do this. But as we go through, we have a volatile char temp, and so this is going to store UCA0 RX buff into temp. Okay, and then UCA0 TX buff, it's going to set equal to temp. By the way, reading UCA0 RX buff is what clears the flag. This while is making sure that the transmit buffer is not full. That's a hard concept, but what happens if we try to write successively to our UCA0 TX buff? Well, we can overwrite before it's done emptying the 1 byte buffer, and we'll give an example of that here in a little bit. Okay, so what does this code do? Well, it just echoes back whatever we type at it to the microcontroller. So I'm going to load this code. Hopefully it runs. And I think it's 6. No. 5. So funny enough, it's working on the same one. I'm going to bring this one up. Okay, proceed, yes. So that guy's going to be running, and what I expect to happen here is, oh, it's a lot of windows to keep track of, is as I type, nothing is happening at all. And one of the possible reasons for it could be that one of the stupid things that I may have done, and I didn't tell you I was going to do this, was I had those two possibly swapped on 1.1 and 1.2. Let's see if that did it. We'll bring that guy back, and now I'm going to start typing, and still nothing is happening. Or I've got to type there. I'm going to do one more swap of those pins without showing it because I'm screwing myself up. Okay, gonna do that one more time. Gonna come up here, type, and still nothing is happening. So we've got something wrong in my code that I still haven't figured out. I'm kind of weirded out by that. We got an interrupt that's going on there. And I'm gonna restart that. So to restart that, I'm going to open up PuTTY, serial, and I guess you guys want to see that. Okay, it's PuTTY. I believe this was COM port 100, baud rate of 9600. So the computer agrees, and I'm still not getting anything through. So we might have to think that there's something wrong. Something someplace. Maybe I have another wiring issue, and everything looks all right, and so nothing's going on. So I'm kind of worried about this. Let me try another one. If we go back to the MSP 430, had the application UART on that one, so let's try that. So sorry about the delay here. Let's go through this. In this case, this would have been 82. And that one's not even working. So there's something really goofy going on here. Let me disconnect it. We're going to do one more time. Well, I think that's really funny that the microcontroller isn't accepting any of that. Got one more trick up my sleeve for this. And really, the possibility that I think I have is that those are crap wires. So let's try 2 other wires. Okay, so we've got that hooked up. I'm going to go back to COM port 100. 100. Okay, bring this guy up. Serial 100. Okay, maybe the wires are backwards again. It's really hard. So the funny part about RX and TX is RX and TX to what? So that's the bad part about this, is sometimes I'm not getting anything on this. I think the microcontroller code is screwed up. And so let's make sure that we have everything on here that looks good. I'm going to load that code one more time in hopes. Now, I thought I had this working, so I'm kind of bummed. But I've got a couple other really cool things to show you in the meantime as well. So let's let that sucker proceed. Okay, we're going to type in 2. Still nothing. I think we still have a breakpoint set. We do. Okay, swap the lines one more time after that. Alright. And if not, we're going to jump on to the next thing. And let me just do this one then. We aren't getting into that interrupt. And what I'm going to do, actually, we're going to do this entire thing. So something's really wildly messed up. And so we're just going to set this equal to a character. And this might work, it might not. I don't know what's wrong with my communication right now. But that sucker is going. Maybe it's thinking that it's running at 16 megahertz. That's a possibility. And so if this happens, if this works, yeah. So there's a communication error. Cool. So let's go and see if we can figure out what it is. Okay? And what we're going to do is, let's see if we can find the right window. I don't think I'm going to be able to find the right window. Yeah, that one. So there's a communication error, and what I don't remember how to do off the top of my head is MSP 430 set oscillator frequency G255. So I've got to go back and someone has 1 megahertz. So this has got to be it. Somebody will say, how? Yeah, this is it. Cool. We're going to go back to the code here. Okay. So I think it by defaulted into something else. I obviously don't want 16 megahertz. I want 1 megahertz. And the reason why I can tell that something goofy is going on is because I'm telling it to send an A and I'm getting a P. So this brings us to a new thing. What are ASCII characters? And so let's see. This will stop running now. And now we're getting A's. So it was all that 1 megahertz thing. Okay? So I'm going to get rid of this guy for right now. We're going to recompile, and now it should echo. And by echo, I'll show you what I mean when we get there. It's going to stop spewing crap. Okay, so we hit that breakpoint. I'm going to get rid of that breakpoint now and run it. And it's going to echo back anything that I say. Let me clear the terminal. Okay, but now I'm going to do something pretty cool. Plus 10. And so this is going to advance 10 characters as we type. And so if I type a capital A, it's just going to give me an A. Now I have to recompile for that to work. So that's going to give me an A. Now I'm going to type an A. It gives me a K. I'm going to type a B, and it's going to give me an L. I'm going to type a C. It's going to give me an M. I'm going to type an M. Gives me a W. Type W gives me a lowercase a. So there's some pattern that this goes through, and so this is backspace. This is enter. L is V. And so what it's doing is it's advancing the characters by a number of 10. And so this is proving to you that I'm not just doing an echo back, that it's doing something. Let's go back to what I had before here. Before I had this dude, it was just spitting out A. Well, that's nice and all. Let's go back to this guy. My string to send. Let's put this in there. And this is just going to be okay. And so what I'm going to do is I'm going to say for k is equal to 0k less than, I don't know how long that is. I'm going to guess 15k plus plus. We're going to do string to send, I think it was, of k. I'm going to put squiggly brackets around all of this, control A, control I. Okay, so string to send, my string to send, my underscore string underscore to send. I'm pretty sure that's right. And so that's going to sit there and spew that stuff off. Doesn't like something, oh, semicolon, of course. Cancel. So what's our issues now? Problems are k is undefined. Yeah, I forgot. K. Volatile int k. All right, we're almost there. And so what this should do once it goes is you'll see it. This is my okay. So let's just pause it for my string is go. So I'm short a little bit, and I need to put 2 more on this up to 17. And the other thing that I'm going to do is I'm going to do this one more time. Twice, actually. I'm also going to do a whole bunch of delay cycles. Okay. I'm not going to do it 2 more times with the same character. Instead, this one I'm going to say is 10, which I'm just putting a value in, not a character. And this one is 13, and those stand for new line and carriage return. I'm going to put in a couple more lines here. Okay, we're going to recompile. And so what this is doing is it's going sequentially through, and now we've got a wait in between, now we have a carriage return there, so there's all sorts of good stuff that we have that we want to pay attention to with this. I really like this kind of methodology. It doesn't use too much, but the cool part is if I type in here, it's still going to echo back anything that I type plus 10. Okay? And so that interrupt is interrupting how it's displaying it, but it's also displaying what I've got in my loop. It's kind of a cool thing that's going on sequentially. Plus I have that big wait in there that we have. So that's all I really want to do for this video. I'll show you some other cool parts in class, but hopefully this is going to be a refresher for all of you. Because of what I'm going to show you in class today. There should be some really cool stuff that we show you in class. Let me know if you have any questions. Thank you very much.